What we are going to do to apply the betting strategy? Very simple actually. So we are going to focus only on bets that have odds higher than 2. So we want to bet on not the favorite, and on matches where the odds of winning and drawing, right, is not correctly, or it's not being reliably computed by the bookies. And usually these are odds where probability is lower than 50%, and in that territory variance is very high, and it's probably where you could see and you could find much value. So odds greater than 2, and usually odds between 2 and 5, but for this case we'll just look at odds greater than 2. But yeah, let's say for illustration purpose we can all bet on all matches. Let's not bet on odds greater than 2. But actually what we're going to do is to select only the matches where the expected points difference between the two teams is between a range. So let's say we can create a rule where we will only look at expected points, expected points difference. If it's lower than, let's say, 4, right, then we bet on a draw. And if it's higher than 4, it means that one of the team bet on higher expected points. Okay, this translates into this thing, into code like this. We will create the predictions as a list. Then we will loop on the data frame for index row in df. Which data frame we loop? We loop on the all the matches, right? The future matches. Match EPL underscore match 10 iter rows. Oh. What we're gonna do? We are gonna extract the home team name first of all, equal row home team. Also the away team. We're gonna extract the away team as well. Away team, and we're gonna compute the home expected points. Points will be what will it be? We have the default stats here, right? This one. The default stats. We will select the place where the default stats, the rows, sorry, where the default stats team, what? Equal home team, and then what we're gonna do? We're gonna select the expected points, which are expert points. Okay, points, and then we're gonna take the values 0, so we get an int. For the away team, we're gonna do the same. Just save it into away expert points, and we're gonna only select the rows where the away team is equal to the away team of the match, and the difference expert points diff teams would be equal to home expert points minus away expert points. Okay. And now we can implement our strategy. Implement strategy that will be, just copy from here. XPDIF less than 4 draw, XPDIF greater than 4 bet on the higher XP. So if exp points diff teams greater than 4, right? The result is home. Result equal home. It means that home team has higher expected points than away team. And the odds Right. The odds will be, what will be the odds? Row PSH. Okay, and then elif absolute value of expect points diff teams less than 4. We bet on a draw, right? Result is a draw, and the odds PSD, they are the odds for a draw, and else I means that the result is away. Okay, and the odds are PSA. And what do we do with this prediction? Now we have a prediction. We call it pred, and we can save it as a dictionary as usual, where the home team is home_team. The away team is away_team, and prediction is result, right? And the odds are exactly odds. Odds is odds. So now we have a dictionary with our prediction, and we can save this dictionary in the predictions list. So now we have, if we execute this, we will have a list of predictions. Newcastle Arsenal away, prediction is away. Bournemouth City away. Ipswich Leicester draw with all the odds. Liverpool Brighton home without the odds. Okay, wonderful. And we can just insert our prediction in the data frame right now. DF, we will call it our slip, our betting slip will be a PD data frame predictions, right? Now we can have a look at our slip as a table. Very nice. Newcastle Arsenal, Fulham Brentford. We have away, draw, home, draw, away, home, draw. Wonderful. Also very, very high odds. Let's have a look. Let's look how did it perform. How did this specific slip that we've built simulating our betting strategy starting from game week 9, starting from match week 10, and taking only the information about the first 9 match weeks. Let's say how did it perform. We can just merge this with the match week, the DF EPL match 10, right? DF slip, and to merge this, like to add new columns to this, which will be the actual result, we can use the merge function. So DF slip will be again DF underscore EPL match match 10. We merge. What do we merge? DF slip itself, and on what? On a home team needs to be the same as away team. There is a home team, and also away team needs to be the same. So we merge on home team and away team. Okay, team. I think I need to include this into. That should be okay. And what do we want to know? Oh, now we want home team as a column, away team, of course. We want the prediction to see if what the model predicted as a full-time result. We want the odds, right? These odds here, and the actual result, which is present in the EPL match 10. If you check as FTR. Okay, so we call FTR, and then we can later compare the prediction with the full-time results. Now let's have a look. Yeah, I think I need to put this into another square brackets, and it should be okay. Yeah, so now we have the sleep, the odds, the prediction, and the full-time results. We see that, for example, we predicted Newcastle Arsenal away win, but actually there was a home win. Also Bournemouth City, we predicted an away win, but it was a home win. But we got Ipswich Leicester right, Liverpool Brighton right, we got Tottenham Aston Villa right, and Manchester United Chelsea right. Cool. So let's assume that, for example, we can assume that we bet 1 unit for each match, and we can say that here we have lost 1, 2, 3, 4, 5, 6. We've lost 6 matches, and we so it's a -6. What? Sorry about that. Change it to code. So we have lost matches -6, but from the other side we have we've gained 263. We won matches. They are like 263. We won 263 from Ipswich Leicester, right? Plus 039 from Liverpool Brighton, 097 from Tottenham Villa, and 281 from United Chelsea. So you can compute. It's computed very quickly. I think we can use Python for this. 6.7. 1 match is 6.7. So this sleep would have totaled us plus 0.7. Let's try to do it with code. This is like, I didn't prepare this, but probably it's very easy to do it with code. Now we have the F sleep, right? What we want to do is create a new column, right? We can call it win. You can call it win. Will be df underscore sleep, and we can apply sleep. We can apply to this a lambda x. What will the lambda do? If prediction and FTR are the same, it will give us a positive plus result of the odds of the odds win. Otherwise, give us a negative. So if, let's say, if x prediction equal fx FTR, what will it be? Not equal, let's say. If not equal, it's -1. -1. If else will be -1 will be because we will lose our hypothetical 1 unit bet. Else it will be x odds -1, right? So because we, for example, in this case, we bet 1 and we get back 263. So we bet we get back 363 minus 1. Let's have a look. And I think that I forgot, as always, axis equal to 1, because we apply the lambda on rows. And now we have the new DF sleep. We can have a look. Perfect. We have DF sleep win. So we can see that we have lost Newcastle Arsenal, Bournemouth City, but we won Ipswich Leicester, and so on and so forth. And to see the full win, win, it will be, of course, the f_sleep win. And then we can call the sum function. And then we can print .win. And we know that we have won 0.79. So let's say for this sleep, we have an ROI. ROI is equal to .win divided by how much we invested. We invested 10 units. And print the ROI. It's a 7.9%, which is not bad. 8% return on investment on this specific bet slip. So yeah, I think that was cool. I think this sums up and concludes the journey, towards building and applying a soccer betting model. One thing that I wanted to say, as I said before, usually these type of models are not suited for betting on low odds. So, for example, in this case, if we only limit ourselves to odds higher than 2, which is the we can do it with the f_sleep, selecting the f_sleep odds greater than 2. Let's see what we get. We get only 2, 4, 5, 6, 8, 9. So only these matches. And then we select only 6 matches. And we select win and we select sum. So assuming that we are doing the assumptions that we are basically only betting on matches where we have high odds, we can get 1.44 win instead of 0.79, which will be a return on investment of 14% instead of 8%. So like this way you can tune a bit your betting strategy towards high value, high return, high risk bets, which will potentially give a much better return. This sums up everything. I hope that you enjoyed the series on how to build a football betting model in a few hours. I would say it could take you less than a weekend to go and build this model. If you are interested in knowing more, I suggest you look at my Gumroad page, where I've published a few books on the matter. I've published a book on how to build a simple football betting model in just a weekend, which is a version of what I've presented in these videos. I've published a book more advanced on how to tune a football betting model based on predictions, odds, and various parameters of the model. It allows you to extract the most value from the models you build, and to tune them to extract the highest return. And I've built a model specifically for Euro 2024, but they can be used. They can be used for national teams predictions, national team tournaments predictions. And I suggest you have a look at the book to get some inspiration on how to do that. And I run also a Telegram channel, which is called Soccer Bets, where I published every week or so, even more often, predictions based on an advanced version of the model that I've showed you in these videos. So if you're interested in these things, give it a try. Have a look at my Gumroad page and subscribe to the Telegram channel. Until then, goodbye and good luck. Bye bye.